Hey, welcome. You know that little lock icon you see in your browser every single day? Well, today we're going to crack it open and see what's really inside. By the time we're done here, you're not just going to see that lock, you're going to understand exactly how it works and how to master it in AWS and Kubernetes. Let's dive in.
So we've all seen this lock, right? We're told, hey, it's secure. But what is actually going on behind the scenes? It's not just a pretty icon. It's the finish line of a super fast, invisible negotiation that literally builds trust on the internet from scratch.
All right, so before we jump into all the cool cloud stuff, we gotta lay the groundwork. We're gonna start with the absolute core of it all, SSL and TLS. You have to get this part because everything else we talk about today is built right on top of this foundation. So at its heart, you can think of an SSL/TLS certificate like a digital passport for a website. It's just a tiny file, but once it's on a web server, it enables that secure connection. And just like a real passport, it's doing a few really important jobs all at once. And here are those three big jobs. First, you've got encryption. This is what scrambles your data so eavesdroppers can't read your credit card number. Second, there's authentication. This proves you're really talking to Amazon.com and not some scammer's website. And third, data integrity, which is a fancy way of saying it makes sure nobody messes with your data on its way to the server.
So how does this magic happen? It's a little dance called the TLS handshake, and it happens faster than you can blink. Your browser basically says, hey, the server flashes its passport, that's the certificate, and then your browser acts like a super fast, super skeptical border agent. It checks who issued the passport, if it's for the right website, and if it's expired. Only when it all checks out does the encrypted conversation begin.
Okay, listen up, because if you take away one thing, this is it. The certificate works with two keys, a public one and a private one. The public key is out there for everyone to see, but the private key, that is the server's most treasured secret. It absolutely positively must never leave that server. The secrecy of that key is what holds this entire system of trust together.
Okay, so we know what this digital passport does, but what's actually written inside it? What information does that border agent, your browser, actually check? Let's pop the hood and dissect one of these things.
Now, just like in real life, not all passports have the same level of authority. With certificates, it's all about validation. The most common one you'll see is domain validated, or DV. It's basic. It just proves you control the website name. Then there's organization validated, OV, which checks that a real company is behind it. And finally, extended validation, EV, which is the super strict one. And honestly, it's becoming pretty rare these days.
So, what does this mean for us working in the cloud? The bottom line is this. In AWS, 99.9% of the time, we're using DV certificates. And why is that? It's simple. They give us the encryption we need, they're incredibly fast to get, they can be totally automated, and they're free. For modern cloud apps, that is the winning combination.
All right, enough theory. Let's get to the fun part. How do we actually put this into practice in the cloud? This is where AWS Certificate Manager, or ACM, steps in and just changes the entire game. It automates what used to be a really painful, manual, and error-prone job.
So why is ACM such a big deal? Well, for starters, public certificates are totally free. That's huge. Second, it handles renewing them automatically. No more calendar alerts, no more late-night emergencies. It integrates beautifully with load balancers and CloudFront. And here's the kicker for security. The private keys it creates are locked inside AWS. You literally cannot export them.
And this really shows the difference. With ACM, the certificate just renews itself in the background. No drama, zero downtime. Your load balancer just picks up the new one. Now compare that to the old way, the way of generating CSRs, manual updates, and high-stress deployments that could take your site down. It's really no contest.
So when you're using ACM, you have two ways to prove you own the domain. There's the hard way, email validation. You have to wait for an email and click a link. It's manual, emails get lost, it's just not reliable. Then there's the right way, the professional way, DNS validation. You add one little record to your DNS one time, and it is automated for life. It's the definition of set it and forget it.
Okay, we've got our free auto-renewing certificate. Awesome. But now we have a huge architectural decision to make. Where do we actually use it? More specifically, where does the encryption from the user stop, and where does our internal, unencrypted traffic begin? This is one of the most fundamental choices you'll make.
So, 99% of the time, this is what you're going to see and what you're going to want to do. It's called SSL termination at the load balancer.
The user's browser talks secure HTTPS to your application load balancer. The ALB does all the hard work of decryption, and then it sends plain, simple HTTP traffic to your servers in the back. This is great because it centralizes all your certificate headaches in one place and keeps your application code nice and simple.
Now there is another way, but you'll see it much less often. This is for things like super strict compliance rules that require end-to-end encryption. Here, the load balancer just passes the encrypted traffic straight through. The actual EC2 instance or the Kubernetes pod has to do the decryption itself. This adds a ton of complexity because now every single one of your backends needs to manage a certificate.
So how does this translate to the world of Kubernetes, specifically EKS? Well, it's almost ridiculously simple. You take the unique ID of your ACM certificate, that's the ARN, and you just paste it as an annotation in your ingress file. That's it. The AWS Load Balancer controller sees that and handles everything else automatically. The best part? When that certificate renews, your pods don't have to restart. There's no downtime. It just works. And I'm going to pause for a second here, because this is huge. If you're interviewing for a DevOps or cloud role, understanding this exact flow, how ACM, the ALB ingress controller, and annotations all work together to give you seamless, zero downtime certificate rotation, this is a massive talking point. Nailing this answer shows you really truly get how modern cloud operations work.
All right, you've officially got the core concepts down. You know how to get a cert and hook it up in AWS and EKS. So now, let's talk about what separates a good engineer from a great one. We're going beyond just getting the lock icon to show up.
First up, lock down your TLS versions. You need to tell your load balancer to only allow modern, secure versions like 1.2 and 1.3 and explicitly disable the old vulnerable stuff. Next, implement HSTS. This is a header that tells browsers, hey, from now on, only talk to me over HTTPS. Finally, for your internal microservices, look into MTLS or mutual TLS. That's where your services show certificates to each other, creating a really secure, zero-trust network.
And just like that, we're back where we started, staring at that little lock icon, but it's different now, isn't it? Now you see the whole story behind it, the handshake, the keys, the validation, the automation, the architecture. So I'll leave you with this thought. Your website has the lock, sure, but after everything you've just learned, can you confidently say it's truly secure?